Hello students, once again welcome you all in my YouTube channel Pacific Chemistry Classes. Students, if you have not subscribed the channel, do subscribe the channel. So today's class topic is allotropes of carbon. This is very important topic for your 10th, 11th, 12th BSc, MSc students. So students, many questions are being asked from these topics in the competitive exam as well. So I am Mahima Laharia, so I will start this class. So carbon has three main allotropes, that is diamond, graphite and the fullerene. So sometimes the questions asked from these topics are like this in the class 10th CBSE as well as your state boards. So if the question is given, a solid element X has 4 electrons in the outermost shell of its atom. An allotrope Y of this element is used as a dry lubricant in machinery and also in making the pencil leads. So first, what is the element X? So students, when they are saying that an element has 4 electrons in the outermost shell. So when you know the atomic number of any element which will have the 4 electrons in the valence shell, it will be your carbon. As you know, carbon family. Okay, what is the atomic number of carbon is 6. So when you write the configuration, it is first shell 2 electrons will come, second shell 4 electron will come. So the first answer will be your what is element X? The element X has a 4 electron in the outermost shell. So when you see the periodic table also, when we come to our 14th group, so see this 4 last electron will come the 4. So as we know that the valency is also the group number. So this first answer, what is the element X, is the carbon. So you have to remember that how much electrons will come in the outermost shell, that is the valency also. So as we know that the valency of carbon is 4, and so this element will be X. As they are saying now, an allotrope Y of an element is used as a dry lubricant in machinery and also in the pencil leads. So as we have heard many times now, carbon have 3 allotropes: carbon, diamond, graphite. So graphite is the answer for allotrope Y. Now next, state whether allotrope Y is a good conductor of electricity or non-conductor. So it is a very good conductor of electricity, and okay, so because of the free electrons, we will discuss this in the detail. Then name one use of the allotrope Y other than the lubrication and the pencil lead. So they are used for making the composites and a reducing agent, and they are also used for making the crucibles and all. So now let us discuss the detail of these allotropes of carbon. One more question is asked, that is name the 2 allotropes other than the allotropes of element X. Means there are 3, the graphite they are asking, but the other 2 are our diamonds and the fullerene. So now let us see what is allotropy and what are the main allotropes of our carbon. So students, the phenomena of existence of an element in the 2 or more forms which has different physical properties but same chemical properties is called allotropy. So what is allotropy? It is a phenomena of existence of an element in 2 or more forms which have different physical properties. Means they will have different physical properties but same the chemical properties. Why they are saying chemical properties are same? Because their constitution is same, but physically they can be different. Means some can be your amorphous type, other can be of the crystalline nature. So these different forms are termed as allotropes. So carbon exists in the 2 allotropic form, that is crystalline as well as the amorphous. So what is crystal means? Crystal means we will say there is a regular arrangement of the atoms and the units. But amorphous, whenever you are seeing any stone, so you see the irregular size. So amorphous means irregularity. So crystalline means it will have a definite shapes. Okay. So the main important crystalline allotropes of the carbon are diamond, graphite and the fullerenes, and the amorphous allotropic forms are coke, charcoal and the carbon black. Charcoal, you have heard that it can be again classified as a wood charcoal, animal charcoal or the sugar charcoal. So these are the 2 important allotropes of classification of carbon. So I will discuss here in detail of the crystalline allotropic form. So students, the most important is the structure of diamond, graphite and the fullerene. So you can see these structures and you can make them. You have to practice it. Okay, so first we will discuss the structure of diamond. As you can see, the structure of diamond is tetrahedral in shape. Graphite, we will discuss there are hexane rings, so many. Okay, that structure is 2-dimensional. This structure is So this is the fullerene. Okay, Buckminster fullerene, after the name of the discoverer, that is our Buckminster fuller. So now you can start, you can write the points also. Structure of the diamond first we will cover. So diamond, each carbon atom is in sp3 hybridization and is linked tetrahedrally to the 4 other carbon atom. So as if you have studied the sp3 hybridization, you can see one carbon is linked with the other 4 carbon atom. Means if you see this much structure, so one carbon is linked with the 4 carbons, means this is a tetrahedral structure, and this each carbon is linked with the other 4 carbons, and the bond angle in tetrahedral is 109.28 degree, sorry, 109.28 minutes or 5 degree, and the bond length in the diamond for the carbon and carbon is 1.54 Armstrong, and the bond angle is 109.28 minutes. So what you have to remember, diamond carbon is tetrahedrally linked to the other 4 carbons. This is the 3D arrangement. There is 3-dimensional network of the strong covalent bond. Okay, everywhere our sp3 carbon is linked with the other, so there is strong sigma bond formation takes place. Because of this strong bond, it is very, very hard, and it's very famous for the high density and the high melting point. Now let us discuss the structure of our graphite. So you can see graphite has our beta plated sheet structure. So this is a 2-dimensional sheet like structures. So you can see in the graphite every carbon is linked with the 3, 1, 2, and this is the 3. So we know that the valency of carbon is 4, but 1 electron is free to move here and there. So from each carbon, when it is linked to the 3, other is 1 electron is free. So that's why this property of the graphite arrangement makes it a good conductor of electricity and heat. So when we talk about the structure of graphite, the important thing you have to remember that it consists of the series of the layers in which there are hexagonal rings, and they are made up of carbon atom. The graphite sp2 hybridization takes place, means carbon is in the sp2 hybridized state, and the various shields or the layers are held together with the weak van der Waals forces of attraction, and the distance between the two layers is 3.35 Armstrong. So the important thing you have to remember, in the graphite our carbon is sp2 hybridized, and in the diamond the carbon is sp3 hybridized. Diamond is our 3D structure and graphite is our 2D structure. Okay, so next is important is our fullerene. So in fullerene you can see one in the carbons are one pentagon structure you can see in the center, and other hexagon units are arranged around it. So this is very, very stable structure, and the fullerenes are the class of polyhedral carbon allotropes, and their general formula is C2N, means if N is equals to 30 it will be 60, means the structure of the fullerene can have so many carbon atoms bonded together. So the pure form of the carbon, it is termed as the pure form of the carbon, as there is no surface bonds like the graphite and the diamond. So most common fullerene is C60 allotrope, and it is also like the saucer ball or the buckyball. It is also termed as the buckyball. So in this structure there are 25 membered, 26 membered rings and 12 5-membered rings, and all carbons are equivalent. So we can say that in this structure is very, very stable. This is the pure form of the carbon. Here also the sp2 hybridization takes place. So many applications of the fullerenes are nowadays. So next are the properties. Sometimes many questions are asked from these points, properties of the diamond, graphite and the fullerene. So let us cover these things. So diamond, okay, so we discussed now in diamond our hybridization is sp3, bond length of the carbon is 1.54 Armstrong. Okay, and what about the purity? It is the purest form of the carbon. Then highest thermal conductivity. So diamond is having the high thermal conductivity, and it is also used as a tools for cutting and the drilling. Okay, but as we know that there is no free electron, it is a bad conductor of electricity. If the question is come, why the diamond is bad conductor of electricity? Because they are not having any single electron, and all the electrons are occupied in the carbon-carbon bond, sigma bond formation. There is no free electron in the diamond. So this is the bad conductor. Diamond is a transparent because of the high refractive index, that is 2.5. Diamond can reflect and refract the light. So this is a transparent substance and its melting point is very high, that is 4027 degree. So it can also the 1-2 degree can vary melting point, no much difference in that. So what about the property of the graphite? So in graphite also is the purest form. Its bond length in our sp2, its sp2 hybridization, its bond length is 1.415 Armstrong, while in the diamond it is 1.54. It is here 1.4 less than the diamond. It is soft in nature. Graphite is soft and slippery. Okay, so because of this slippery property, they are used as a lubricating agent, and the conductivity is very high. This reason is asked. Why the conductivity is very high? Because only 3 electrons of each carbon are used in making the hexagonal rings in the graphite, and the 4 electron of each carbon is free to move. This makes the graphite as a good conductor of heat and electricity. Next property, opaqueness. As we know that the pencil map, you see a pencil black. So graphite is a black substance. It is a metallic luster, but it has a shining. So we can say it's a metallic luster, and its melting point is 3500 degrees centigrade, and the density is less than the diamond. It's 2.22 gram centimeter inverse cube, and it is thermodynamically stable than diamond. It is thermodynamically more stable than diamond. And amorphous carbon, our charcoal, soot, lamp black are the fine crystals of the graphite only. When we talk about the amorphous allotropes of the carbon, all these are the types of graphite only. So I hope the points of the graphites are clear to you. So maximum questions are being asked from the graphite, so you should learn them very nicely. Next, our fullerene. So we can say that about the purity, this is also what they are writing here. They are the only pure form of the carbon is they have a smooth structure which with the dangling bonds, means they don't have means roughness or like that. So as we can say that diamond is also pure, graphite is also pure, but fullerene is considered to be the more pure. Then the fullerene being covalent are soluble in the organic solvent. So these compounds are soluble in the organic solvents. They show the electrical conductivity also, because here also sp2 hybridization, so one electron will be free. High chemical reactivity, and fullerenes can trap or cage metallic ions like lithium, cesium, etc. So as their structure, we had seen a pentagon, hexagon, so they can trap any element like our lithium, cesium, etc. in their structures, and by passing the electric currents, these are converted to the negatively charged cage called fullerides. So by passing the electric current, we can convert them to the negatively charged cage called fullerides, and they can react with the group first elements to form the superconductors. Means what are the group first elements? We know that Helena, Kirov, Faryad. So these are our first group elements: lithium, sodium, potassium, rubidium, cesium, francium. So they can easily react with the first group element to form the superconductors. What are the superconductors? They have high conductivity at our below the 18 Kelvin also. That means it can carry the electric currents with the zero resistance. So K3C60 is a good example for a superconductor. Now next we will talk about the uses of diamond, graphite and the fullerene. So diamond, we know that it is a hard substance. It is used for cutting the glass, making the borers for the rock drilling. It is also used as an abrasives. Okay, then making the gems and jewelry. आपने देखा ना, diamond is used for making the jewelries and all rings and ornaments. And what is the measurement? We are saying that 1 carat is equals to 200 milligrams of diamond. If it is a 1 carat diamond, it has 200 milligrams of diamond. Because of its extraordinary sensitivity to heat rays, it is used in high precision thermometer. Because it's very sensitive to heat, it is used for making high precision thermometer. Means where high accuracy is needed, we will use our diamond. So manufacture of the tungsten filament for the electric light bulbs. It is also used for the manufacture of the tungsten filaments. Then it is also making the dies for the precision drawing of the various metal wires. Means when you need to make the wires of a particular thickness or thinness, we are using the making the dies. Means we will make this type of the structure from diamonds, and the wires can be drawn easily. Then next is the Uses of graphite. So graphite is used as a lubricant for heavy machinery running at a high temperature. Means lubrication, sometimes we are putting oil and all na, so that our machinery will run smoothly. So graphite is used, because if we use oil and all na, high temperature, it will not work. So in place of oils, we will use our graphite as a solid lubricant, or we can also write as a dry lubricant. It is already asked. It is mixed with the clay or wax. It is used in the lead pencils. We know we are writing with the pencil now. So when it is mixed with the wax or the clay, it is used as a pencil leads, or we can say it as a black lead also. Graphite is used for making the electrodes for the dry cells. In 8th standard, we study a dry cell, Lagrange cell. So in the center, one electrode is there. That is carbon electrode. We are saying it is made up of graphite. So they are used as a moderator for fast moving neutrons in the nuclear reactor. When the chain reactions are going, when we have to control it, so we are using the moderator, which are made up of graphite. So it is also used for making the crucibles, which are used in high temperature in the refractory, also inner to the acids and the bases. So sometimes we need crucibles which are non-reactive to the acid and the bases. So these are also made up of graphites, and they can sustain very high temperature. They are used for reducing agent in the steel. So they are also used as a reducing agent when we are making the steels and all. So they are used in electrotyping and electroplating, simple uses. Then composite making. So they are used as a composites used in the aircraft, canoes, fishing rods, tennis rackets, and as they give the high strength and the lightweight material. Composite means sometimes we need to fill the things. Okay, so we will make this of the graphite composites, उसको packing करने में help करते हैं. Okay, aircraft and canoes. So next we can see the applications of the fullerenes, uses of fullerenes. Applications in the nanotechnology. What is nanotechnology? When we reduce the size of any particle up to the nano, means 10 to the power 9 minus 9. So this size is nano. So when the something is very much reduced, that is nano size. So you can see the thickness of air that can be considered to the nano size. So they are used for applications in the nanotechnology, semiconducting material making, and insulation of rockets, missiles against the friction, vacuum, and the pressure. So these are the main uses of our diamond, graphite, and the fullerene. You can write it down. You can take the screenshot, because many questions are being asked from this uses of. Now next is sometimes they are asking the difference between our graphite and the diamond. So we will just discuss diamond. It is very hard. It is very high density. That is 3.5 grams per cc. But in graphite, it is soft and relatively low density. It is bad conductor of heat and electricity due to the absence of free electrons. It is good conductor of electricity and heat because of the free electrons. It has three-dimensional network structure, as carbon is linked to the 4 other carbon atoms, and it has a sheet type structure, as each carbon is linked to the 3 carbon atom. And next, their chemical reactivity is low. Their chemical reactivity is very high. Carbon is sp3 hybridized, and the bond length is 1.54 Armstrong or 154 picometers. Here the carbon is sp2 hybridized. The bond length is 142 picometer or 1.42 Armstrong. The bond angle is 109 degree 0.28 minutes. Here it is 120 degree. Then the thermodynamically diamond is less stable than graphite, but our graphite is more stable. Then that they are transparent to X-rays because of the high refractive index, and they are not transparent. They are opaque in nature. So dear students, it is all for the allotropes of diamond, graphite, and the fullerenes. So this is very important. So I hope you like the video. Please share with your friends, complete your notes. And once again, all these questions we see in the beginning, they name one uses of allotrope. So we have many uses, anyone you can write other than the lubricant and the pencil leads. So I hope this question is clear why the graphite is a good conductor of electricity, because the free electrons, as we see now, 3 electrons are only occupied. See, the valency of carbon is 4. But in the structure of graphite, we are only using these 3 electrons. So this 1 electron is free. That's why it is able to move here and there. So this free electron is responsible for making a graphite as a good conductor of electricity. See, the length between the distance between the two layers is 3.35 Armstrong, and our carbon-carbon bond length is 1.42 Armstrong. In the fullerene, this length is 1.453 Armstrong, and other is our 1.383 Armstrong. So I hope this points you can note down, and hope you will do it well. Thanks for watching. Do share with your friends, and if you have not subscribed the channel, do subscribe.